thanks for the introduction. So yeah, like already said, I'm Johannes. I'm working on the FoundationDB Kubernetes operator. I work for Apple as a site reliability engineer since 2020. And this talk is an overview about the FoundationDB Kubernetes operator, some challenges that we had to solve in the area of running FoundationDB on Kubernetes, and a little outlook on what we have planned for the FoundationDB Kubernetes operator. So to start here, the FoundationDB Kubernetes operator is open source since 2019. So it's on GitHub. If you want to use it, you can take a look at it. You can try it out. You can run clusters with it. The main target of the FoundationDB Kubernetes operator is not surprisingly the target to run FTP on top of Kubernetes. It supports and manages the FoundationDB configuration and all the required Kubernetes resources. So that includes all the pod resources, services that are created. And it also manages the FoundationDB configuration itself, which means running different configure commands, for example, or ensure that all the processes are started with the correct set of knobs, for example. I might have forgot in the beginning, in the introduction, it's not required that you know FoundationDB too well, but it's definitely not bad if you have some experience in running FoundationDB. If not, most of the stuff should be hopefully make sense in the context of FoundationDB. And it would also be great if you have some background, at least from the concepts of Kubernetes. So I'm not doing an introduction about Kubernetes or FoundationDB itself. If you need any information from that, you can maybe take a look at some talks that are out there and then get back to this talk later because the talk is recorded. Okay, but if there are any questions, also please write them in the channel or ask them later at the end. Since I'm sharing my screen, I'm not able to see any messages in the in Teams. So yeah, that's probably the easiest. So the operator itself gets all the required tooling like FTP CLI or the client libraries with init containers. We decided to take that approach because that's the most flexible approach from our perspective. So the operator version itself is not coupled to a specific FTP CLI version, for example, but you can decide by yourself what FTP CLI versions the operator should be supporting, for example, what client libraries should the operator support in order to manage FTP clusters. And that also makes it a little bit more flexible in testing maybe re-released versions from FTP CLI, for example. The operator supports multiple ways to run FoundationDB clusters on top of Kubernetes. It supports multi-region deployments, single region deployments, and 3 data hall deployments. But I have a dedicated slide on that to show you the flexibility of the operator here. We also have a kubectl plugin. The kubectl plugin has multiple different commands that you can use to troubleshoot, for example, your FoundationDB cluster. That the kubectl plugin hopefully help you to debug any issues that you have. Or it will also help you in case you want to train, for example, a specific node in Kubernetes, or if you want to remove a specific pod or process in the FoundationDB cluster for some reasons, for example. We have alpha support for backup and restore. You can already use the operator to back up your FoundationDB cluster and to restore into a new cluster from an existing backup. We keep it in the alpha status here because some features are still missing. So one pretty important feature that is missing is the expire command from FTP backup. So per default, the operator will start a so-called continuous backup. So the backup is be doing the whole time. So that means without the expiration of the data, the backup will be growing and growing and growing. So that's obviously quite an important missing feature that you would need to implement today outside of the Kubernetes operator, but we have plans to implement that in the future. Right. So the FoundationDB Kubernetes operator handles the whole life cycle of an FTP cluster. The creation of the cluster is the first step. Then you probably will upgrade your FoundationDB cluster at some point in time. We have a dedicated slice for the upgrade scenario because, at least from my point of view, the upgrade mechanism in FTP is quite unique and quite interesting, especially if you want to do it on Kubernetes. Then pretty simple or common things like you want to change an op, for example, that will be handled by the operator. Configuration changes either in FTP itself, for example, the change of the storage engine, or configuration changes on the Kubernetes side because you want to give your pods, for example, some additional memory. It can also handle the migration between different Kubernetes clusters and namespaces. Depending on your actual setup, you might need some additional tooling around it, but in general, it will support that. It can detect failed processes and replace them. It can also detect pods that are running on a tainted node and can replace them. I have a few more examples later on where that might be useful. And it can also use the maintenance mode. If you don't know the maintenance mode yet, I'll talk a bit more about it in a later slide. So FoundationDB deployments on Kubernetes are pretty flexible from my perspective. So you can run a single FTP cluster in a single Kubernetes cluster, for example. You can run a single FTP cluster across multiple Kubernetes clusters. You could also run a single FTP cluster across multiple Kubernetes namespaces in a single Kubernetes cluster, for example. You can run a multi-region FTP cluster in a single Kubernetes cluster. We can run a multi-region FTP cluster across multiple Kubernetes clusters. So the first case for the multi-region FTP cluster in a single Kubernetes cluster is, I think, not a common case, but will be useful or could be useful for testing scenarios, for example. We use this to test, for example, the multi-region setup in our end-to-end tests because we don't want to spin up too many Kubernetes clusters for doing that. And then the multi-region FTP cluster across multiple Kubernetes clusters also supports all different FoundationDB multi-region configurations that you can think of, like having a primary, a remote, and a satellite, for example. That would be the classical triplet configuration, or by having a primary satellite, a remote satellite, and a remote cluster, and maybe some more exotic multi-region configurations like having a primary, two primary satellites, two remote satellites, and a remote cluster, depending on your needs and your underlying infrastructure that you run Kubernetes on. It also supports 3 data hall, and you can run 3 data hall across a single Kubernetes cluster, and you can run 3 data hall also across multiple Kubernetes clusters. 3 data hall is a good choice if you run on public cloud, for example, and you want to use the availability zones that most public cloud providers offer. And then you would normally spin up one single Kubernetes cluster and then run a 3 data hall FTP cluster on top of that. Right. So how does that look like? I only visualized here 2 Kubernetes clusters. In a real-world deployment, you would have at least 3 Kubernetes clusters. I just didn't want to make the slide too full. But since the FTP uses the coordinators, which is a majority-based system, you normally want to run at least 3 Kubernetes clusters, or your FoundationDB cluster on 3 Kubernetes clusters. So there is the FoundationDB cluster custom resource definition, and that basically defines how your FoundationDB cluster should look like, how many processes you want to run, which knobs should be deployed, how many memory the different pods should get, for example. Then there is the FoundationDB backup custom resource definition that can be used to start a backup, pause a backup, or abort a backup. And then there's the FoundationDB restore 0D to restore a FoundationDB cluster from an existing backup. Most of the time, you will probably work with the FoundationDB cluster resource. Then the FoundationDB operator takes the current FoundationDB cluster resource. That's also referred in Kubernetes terminology as the desired state. And then the operator will basically fetch all the pods that are part of that cluster, the persistent volume claims for stateful pods, for example. Then it will fetch the so-called machine-readable status from FoundationDB that contains a lot of information around the cluster itself. And one of the most important bits for the operator is the processes list. So that processes list contains all the processes that are part of the FoundationDB cluster, the version it currently runs on, the address, for example, the start command line. So you see all the knobs that are deployed for the current process. And all of that information will be put together by the operator, and that's the current running state. And then the operator basically compares the desired state with the running state. And if they're not the same, the operator knows, okay, it has to take some specific actions to actually converge to the desired state. So in the current example, we have, for example, on the left side in the Kubernetes cluster 1, 3 pods. If you would change that to 4 pods, for example, then the operator would automatically create a new pod. And if that pod would be a stateful role, like a storage process, for example, then the operator would also create automatically a persistent volume claim for it. The operator itself currently manages bare pods, so we don't use a deployment or a stateful pod, for a stateful set, for example. And the reason for that is that we are not seeing a huge benefit in that. And the operator is basically responsible for managing those pods by themselves. What you often see in different or in other operators is that you have the operator managing a stateful set that only contains one single pod. And we just wanted to remove that redirection because we didn't see a huge value there. So that's the reason why the operator itself manages bare pods right now. If you have multiple FDB operator instances, like in this example, they will also coordinate over FDB itself. I'll get into that a bit more into the details in the upgrade sections. But one example here is that we implemented in the operator a lease mechanism so that each operator instance will try to get a lease, and only the one with the active lease is able to perform some potential disruptive operations. One example would be here, for example, doing an exclusion of a specific process, because that can always cause a recovery, and that could be, in the worst case, lead to a few seconds downtime, for example. And that's the reason why we want to coordinate that if you have multiple operator instances. Right. And we basically decided to implement this mechanism where we have multiple loosely coupled operator instances to make sure we don't have one single big point of failure. Instead, we have multiple operator instances, and they are communicating over FDB, or rather coordinate over FDB, to make sure that some specific actions are coordinated. So the FDB operator has some failure detection built in, or misconfiguration detection also. For example, in this case here, when the node fails here, the operator would notice that the processes of those 4 pods are not reporting anymore. And after some threshold, which you can configure actually on the FoundationDB cluster resource, the operator would start a so-called replacement. And the replacement basically means that the operator is just creating a new pod for this currently broken pod as a replacement. And then it will start a so-called exclusion in FoundationDB. And that exclusion will make sure that the process is not hosting any data anymore. And then the operator basically waits until the process is so-called fully excluded. And that means the operator ensures that FDB tells the operator that the process is not hosting any data anymore. Once that is done, the operator is allowed to delete that pod, and then it will actually run another command, which is called the include command, and that will then remove the process from the exclusion list again. The default setup for those exclusions right now is basically using the IP addresses of those processes. That has a few drawbacks in a sense that if the pod gets deleted and recreated, the IP address will eventually change, and then the process would not be excluded anymore. And therefore, you can actually use something called locality-based exclusions, because the locality will be the same even if the pod gets recreated. And that's the feature that you should be using if you use FoundationDB 7.1, 41, or newer. All right. So, and we also have a feature in the FDB operator to remove pods that are running on tainted nodes. The idea here is that if something puts a taint on a node because the node, for example, is under resource pressure or has some other problems, or maybe should be reserved for some other workload, then the operator can automatically start a replacement for those pods running on that node. And that can also be used flexible in a way that if you want to upgrade a node, for example, and want to make sure that it's evicted beforehand, you could use that same feature. That's an optional feature that you can enable if you want, but by default, that feature is actually disabled. The normal failure replacement is enabled by default. Right, FoundationDB maintenance. So FoundationDB has a feature that's called maintenance mode. And the idea of maintenance mode is to reduce unnecessary data movement. So you can tell the data distributor with the maintenance mode that all the processes in the zone might fail because of planned maintenance. And in that case, the data distributor will not re-replicate the data. And in general, the data distributor is the component that is the one that replicates data again. It does a lot more things actually, but that's the gist of it. That's the most important here for the maintenance feature. And the operator can make use of that when updating storage pods, because the maintenance mode is only important for storage processes. And that has the benefit that if something changes that requires that all the storage pods are recreated, for example, the operator can do that zone by zone, so that the customer is not noticing that rollout, for example. And with the maintenance mode feature, that also makes sure that we are not moving data around in the cluster unnecessarily. That's especially important if you have to pay for the data movement, for example, or it's also important if just to reduce the traffic on the cluster, because you know that the pod will come up after a few seconds or minutes, depending on your Kubernetes deployment. More interestingly, you can also use that maintenance mode feature with an external integration. That external integration must be built by yourself or your tooling. And basically, we have a documentation about that in our FoundationDB Kubernetes Operator repository. So you can follow those steps basically. But you can think of something like you create a cluster maintenance controller, maybe another fancy name. And then you could add storage pods to the maintenance list before you actually reboot the node, for example, or upgrade the node. Once you added those storage pods to the maintenance list, then you upgrade the nodes. Maybe the pods are unavailable for a few seconds, minutes, depending what you actually upgrade. And then the operator will remove automatically the maintenance mode after all the processes have been restarted. So that's quite a handy feature, in my opinion, if you want to implement something for your Kubernetes upgrades, for example, to have a minimal impact on FoundationDB there. But yeah, it's something that you have to implement by yourself, because all the different Kubernetes deployments are quite different. But yeah, there is at least a possibility to integrate that, basically. And that should also give you a better experience if you run on a Kubernetes cluster, for example, that must be upgraded, and you don't want to migrate all the pods to a new set of nodes, for example, or maybe that's not possible. Right, and here we go to the next and the most interesting topic from my opinion. So FoundationDB upgrades are quite interesting and quite unique from my perspective for a data service. We start with the most simple case, which are the patch upgrades. So patch upgrades are compatible. That means our patch upgrades are fairly simple, and we just can start updating our storage pods zone by zone so that we are not taking down too many storage pods at the same time, and that we reduce the risk of losing data, for example. For the transaction system, we decided to replace the whole transaction system so that it includes all the stateless processes, the log processes, or the transaction processes at once. And that means we have the old set of the transaction system pods. And besides that, we create a new set of transaction system pods in the new version. Once the new set of transaction system pods are up, we will exclude the old processes. And then we will delete the old processes once they're fully excluded, basically. And the reason why we are doing that is to reduce the number of recoveries. So if you're new to FoundationDB, a recovery is a normal mechanism here to recover from any failures or configuration changes. And basically, you want to minimize the number of recoveries in the operator, at least for planned maintenance. Because otherwise we have potentially problems with too many frequent recoveries can cause a bad customer experience during upgrades, for example, or a recovery can, for maybe different reasons, take longer than expected, and then you would also have a bad customer experience. So that's the reason why we want to reduce the number of required recoveries in that case. And it's quite surprising. Maybe not surprising, but it's quite interesting how many things can cause a recovery. The maybe more obvious ones are exclusions and inclusions. Then also coordinator changes can cause a recovery. Configuration changes can cause recoveries. And then the other ones like failures, for example, can cause a recovery. And potentially some other configuration changes that could cause a recovery. But yeah, in the end, for the patch upgrades, our goal was to minimize the recoveries that are required based on planned actions. The major minor upgrades are a little bit more interesting and require some additional, maybe complex orchestration. Because the requirement for major and minor upgrades are currently to restart all the processes at the same time. I quoted at the same time because obviously we are a distributed system and restarting all at the same time is not really possible, but we want to restart them in a really short time window, actually. The reason why we have to do it is because major and minor versions upgrades are not compatible. I believe there are some changes now with 7.1 and 7.3. But it's still something that we do in the operator right now. And maybe in the future, when FDB provides that compatibility, we maybe rethink this process. But in general, it's maybe sounds like a pretty unique process, but it's fairly well tested, or it's well tested in our system, and it works surprisingly well, actually. So once you update the version in the FoundationDB cluster resource, the first thing that operator is doing, it actually checks if it can upgrade to that version. So it checks that all the required tooling is present in the operator image itself, or in the operator container, actually. Then it will check or update the sidecar image to a new version. So we use a pretty handy feature from Kubernetes that you can update a container image in a pod with multiple containers, and all the other containers are still running, and you only update that one specific container. So that means we update the sidecar image to a new version. That means the Kubernetes kubelet will update the image for this specific container. All the other containers of that pod keep running, and the FoundationDB cluster keeps running the whole time for this. That means you basically are not limited to the pull throughput for all the cluster, for example. So we don't have to wait until all the images are pulled on all the different Kubernetes nodes. Once the sidecar starts up, it notices that it's running with a different version than the main container and basically copy the FTP server binary to a shared volume. I also have some visual graphics later on to hopefully make the process a little bit more clear. And then the operator will also update the so-called FoundationDB monitor configuration. So FoundationDB monitor is that component that runs inside of the pod that will actually start the FTP server process. And the FoundationDB monitor configuration will be updated to point the binary to the new FTP server binary in the shared volume, but FTP monitor will not restart the FTP server process right now. So at this stage, we have all the pods running with the new sidecar image. All the pods have the new FTP server binary present in the shared volume, and we have all the pods have the new FTP monitor config present. Then the operator makes sure that all the processes in the FTP cluster are ready. So the operator instances across different Kubernetes clusters will coordinate over FTP itself. So once all the processes are ready for the local pods, it will be updating that list in FoundationDB itself under a special key. So not the special key that you would know from FTP, but basically under predefined key space. And once all the pods or all the processes in the cluster are present in that list, the operator knows, okay, I can move forward, I can restart all the processes. The one operator will take a lease or get the lease rather, and that one operator instance with the lease will start the cluster-wide restart. You will often hear that as a cluster-wide bounce. And now technically all the processes are coming up with the new FTP server binary version that is present in the shared volume. And technically at this point, the cluster is upgraded, but we still have to do some additional cleanup because the main container is still running on the old version tag. So we have to perform the same steps at this stage now. So we have to replace all the transaction system pods again, and we have to update all the storage pods basically zone by zone. And that's basically how the upgrade mechanism works in the operator. And if you want to, so you don't have to use the operator obviously to run FoundationDB on top of Kubernetes, but you heard of all of those steps that we perform, and we added quite a lot of different safety checks between those stages, because if you run a large fleet of FoundationDB clusters or a large FoundationDB cluster, you can assume that things might go wrong during the staging time, for example. And we also have a more detailed document if you want to read over that later. So you might want to either review the logic in the operator itself, or you maybe want to see if the FoundationDB Kubernetes operator might be a good fit for your use case. So I'm not trying to say use the FoundationDB Kubernetes operator at all. That's your decision, obviously, and that depends also on your case, how you want to run those things. But I think based on only the upgrade path, that shows you that the operator has some logic in it that should prevent you from all the bad mistakes that you could make. All the safety checks that were added here. And here is a visual representation of what I just said, basically, to hopefully make it a little bit clear. So on the left side, we have basically the starting case. The cluster is running in its version 7.1.57. The shared volume is empty because the sidecar is running on the same version as the main container. And now someone goes to the FoundationDB cluster resource and types in the new version like 7.3.43. And then the operator will update for this specific pod the sidecar, actually for all pods in the cluster. The sidecar will notice, oh, okay, my main container runs in a different version. It will copy the FTP server binary to the shared volume under /bin/7.3.43/FTP server. Then the FoundationDB monitor config will be updated. Once that's done for all the processes, the operator is doing the cluster wide bounce, and then the pod gets actually recreated. In the case of a storage pod, in the case of a transaction system pod, the pod will be deleted later because it will be replaced. So a few things that we improved for FDB and for operator since we started our journey in 2019. I think the most important improvement in FDB itself was the gray failure detection. So FDB itself already has some failure detection, and it's fairly good at detecting hard failures, but it's not that great without gray failure detections on detecting gray failures. And that could be something pretty similar or pretty simple, like one process in the whole cluster has like elevated latencies. So you maybe want to remove that one because it's running on a bad Kubernetes node, for example. And all of that can be done with gray failure detection. Gray failure detection is already present in 7.1, so you could basically make use of it. And it's quite helpful in the case of a distributed system that runs on a Kubernetes cluster, and helped us a lot in stabilizing FoundationDB on Kubernetes. There was also added support for automatic failover. Part of that is also in the gray failure detection, but it also allows you to fail over if you run a multi-region setup, for example, so that FDB notices, okay, I'm not able to recruit all the processes that are required in my primary site, for example, so I'm failing over to the remote site. The other two are basically added to because of the more dynamic nature of Kubernetes. So things can change, like an IP address if you recreate a pod, for example. So FDB added locality-based exclusions. So you can exclude processes based on the locality. That could be a zone, or in the operator case, we call it an instance ID, because we have a one-to-one mapping with a pod and an instance ID. And we also, or FDB also added support for DNS-based service discovery. DNS is not used in the critical path, but it's actually used in the cluster file, so that you can use DNS names in your cluster file, which is a little bit more flexible than using IP addresses, because if you have a coordinator, that coordinator gets recreated, for example, that would mean the cluster file is now outdated because the IP address has changed. If you use DNS-based service discovery, that can be reduced. And without DNS-based service discovery, you also have some potential risks. Like, let's assume we have 5 coordinators and all of them are getting restarted or recreated at the same time for some reason from some external source. Then all those 5 coordinators get a new IP address, and then your cluster file is technically outdated and your cluster would be unreachable, and you have to manually fix that. The kubectl plugin actually has support to fix that, but it would be better if you just use DNS-based service discovery, so that everything just works again once the coordinators come back again. We also added some features in the operator to support the whole life cycle of FoundationDB clusters on Kubernetes a bit better. One of them is automatic replacement of pods. So we replace processes or pods, for example, if they are not reporting to the cluster anymore, or if they are like excluded manually by someone, or if they report, for example, process errors, IO errors, for example, or some other conditions that the operator will act on. Then the automatic training of tenant nodes has helped a lot for us, because there's quite some tools around there that will automatically add taints on nodes that have some problems. One of the most prominent examples is the node pod detector, but also Kubernetes itself will add some taints to nodes if they're currently under resource pressure, for example. Then we have in-depth end-to-end testing. We use Chaos Mesh for some chaos injection. We also added some bugification in the operator to support some different cases that are not that simple to mimic with Chaos Mesh. All of those tests are open source, so you can go to the operator repository, for example, run those tests if you want. You can look at those tests to see if everything is correct that you think is important, or you can just use those tests, for example, to validate if your Kubernetes cluster supports the operator or if you want to change anything. We spent a lot of time, and we're still in the process to make it even better on reliable upgrades and rollouts, because upgrades are obviously critical for your software, and you want to make sure that the upgrade and the rollout process is as smooth as possible, and in the perfect world that your customers have no issues with that. So they are not observing any impact during the upgrade process. So a little bit outlook on what projects we are potentially working next. We don't have a roadmap on the GitHub repository yet, but that's something we have to plan on to make sure that we can present a little bit better to our community what we're currently planning on. So we have the unified Kubernetes image. This feature is actually released, so hooray. So you can use that feature, test it out, and if you want to use it, you can use it, but that will basically replace the old sidecar approach. And currently we have a sidecar image and a main image, which has a few challenges by itself. We combine those two things in a purpose-built FTP monitor for Kubernetes, which is the FTP Kubernetes monitor. And basically, it reduces some coupling between the operator and the sidecars, because in the previous world with the sidecar, the operator was making like HTTP requests to get some information from the sidecar. And we basically removed that by the FTP Kubernetes monitor, just adding some additional metadata or information in the pod annotation so that the operator itself doesn't have to make all the HTTP calls. And it also has the benefit that the sidecar, during an upgrade, the sidecar image is now the same as the main image, obviously in a different version. But that has basically the benefit that the image cache of the Kubernetes node is already hot or warm, because the image was already pulled once, and then the restart of the actual pod will be much faster than compared to like having two different images. That might be only a small nuance, but that's still a small win. And the FTP Kubernetes monitor currently lives in the FoundationDB repository. Right, and like I said, this feature is released now, so you can use it and test it out if you want to. We plan on a new feature that's called logical fault domains. The idea is to put some logical fault domains on top of actual fault domains. And the reason why we want to do that is that we can make better scheduling decisions for the operator, so that operator maybe is able to better rebalance different pods across the different localities. And it also has the benefit that the operator doesn't have any need to actually read node labels, for example, because that would be a requirement if you read any information from the nodes itself as a fault domain. And some more ambitious goals in an auto-selection system. Basically, that we implement some heuristics in the operator, similar to the horizontal pod autoscaler, so that we can make use of the elastic compute and reduce manual toil for scaling, for example, so that you can define you want to run your FoundationDB cluster in this range of capacity, for example, and then the operator can dynamically create or delete pods depending on the current workload. That obviously will require some additional thinking, especially in the light of recoveries, because if you add a new transaction system process, you also need to change the configuration. But at least for the storage subsystem, it's potentially a little bit easier. But yeah, that's something we have on our roadmap. Then we want to look at a global multi-cluster operator. The idea is to simplify the setup and management of FoundationDB clusters that are running across multiple Kubernetes clusters. Right now, you still have to use some additional tooling to make sure that you create FoundationDB cluster resources in the different Kubernetes clusters. You have to make sure that they are somehow in sync with the configuration. Otherwise, you might observe some potential issues. You can use something like a GitOps approach for that, for example. You could use your favorite CI/CD pipeline for that. But in the end, the goal for us is to have the global multi-cluster operator to just make it easier to create a new deployment, and then just like fan out and create the more specific FoundationDB cluster resource in the actual Kubernetes clusters. And that will also help in the future with migrating from different Kubernetes clusters and make it easier so that the whole community can benefit from that. And last but not least, we obviously want to implement the complete backup and restore procedures so that we can say that the backup and restore processes in the operator are now stable, and you can use it without having to add any additional outside resources. And I know that was probably a lot, and that's still on the high level. There are still a lot of topics that we could deep dive into. So that's the end of my talk. I only have a few things. So if you're interested in the operator, please look at it in the GitHub repository. If you have any questions, come to the forum. If you observe any bugs, feel free to open a GitHub issue. There's a bug report. If you think anything in the operator is missing and you're trying to use it, feel free to create a GitHub issue as an enhancement. And if you're looking for anything new, we are actually hiring in the FoundationDB team. So if you're up to something new, let me know. And we also like hiring across multiple different orgs. So, and with that, thank you for having me. And yeah, any questions?
I had a question, Johannes. During the upgrades, you mentioned that we try to replace the transaction, I guess, system all at once. Does that mean that during that time, like, let's say we try to commit, would it just throw an error?
No, so commits will still work.
Okay.
What's happening behind the scenes is that the old pods will be still there, and then the new pods will be created. And only when all the new pods are there, the old pods will be excluded. So from the client side, you shouldn't see any issues.
Got it. Okay.
So you might see a small or minimal unavailability because of the recovery, but that should be only, or based with the retry mechanism from FTP, you should notice that.
Okay, got it. We have one person with the hand up. You can ask your question.
Do you hear me?
Yeah, we can hear you now.
Yeah, thank you for this presentation. I have just a question, because it is common that many companies, even they are massively using Kubernetes on their production for, it is limited for microservices, and usually they are afraid to use Kubernetes for everything related to stateful data, like databases. So my question is just if did this this tool or maybe another tool is already pushed in production, like to run FoundationDB in production under Kubernetes, and if you already encountered some issues is specifically related to Kubernetes or things like that. Yeah, thank you.
Okay, yeah. Okay, great question. So we use FoundationDB on Kubernetes in production. We observed some issues. I don't. Yeah, that's nothing really super interesting. So nothing that I can go into detail here. But we had some learnings, especially around how to manage things in the proper way. And I think most of it was more around how to efficiently manage FTP itself, like the recovery logic, for example. And regarding data services on Kubernetes, there's also the DOK, like the Data on Kubernetes community, where different people from the community present that you can run data services on Kubernetes. Because in the end, it's depending on your underlying Kubernetes infrastructure, it's just a different way on how you want to start or run your processes. I mean, in your bare metal world, you probably have something like Ansible, Puppet, or your own home-built process management system, for example. And now instead of using your homemade process management system or anything else, you basically just use Kubernetes to schedule those processes. So there are a lot of things that we still want to improve there. We are not yet done with our journey, but I think we're on a good track there. And one thing that we want to improve there is basically the scheduling and how to better lay out FoundationDB on Kubernetes. But so far, we haven't seen any real major concerns where we would say we don't want to proceed that path anymore, for example. I hope that makes sense. I'd probably stop sharing my slides because I don't see any hands or anything else.
Hey, Johannes, I have a question.
Oh, yeah, sure, go ahead.
Yeah, so I want to know, to connect to a FoundationDB coordinators, you need coordinator IPs, and the FDB cluster 5 has all the IPs. So how are you running the coordinators? Are you running a coordinator on each one pod on a machine? And using the host network, because when we try to explore this, that's kind of a limitation that came across.
Right, that's a good point. Right now, you have the requirement that the IP addresses that you use for FTP must be reachable from the application. So that either means your application must be running in the same Kubernetes cluster, or that means your Kubernetes cluster must provide some routable IP addresses that can be reached outside of the Kubernetes cluster. In our case, we have a mixture of both, but it's not something that is solved by us in the operator. It's more or less a problem of the Kubernetes infrastructure from our point of view.
Mm-hmm. Okay.
But yeah, that's a limitation of FTP right now.
Yeah, thank you.
Cool. Thank you, Johannes.